Welcome to the fascinating world of Albert Einstein, a name synonymous with brilliance and curiosity. As one of history's most influential physicists, Einstein forever altered the landscape of science. His groundbreaking contributions, especially the theory of relativity, reshaped our understanding of the universe. Imagine a world where time and space are fluid concepts that bend and stretch. This revolutionary idea challenges our perception of reality. Relativity isn't just a scientific breakthrough, it's a key unlocking the mysteries of space and time. Join us as we explore how this theory revolutionized physics and paved the way for countless innovations. We'll unravel the complexities of relativity, starting with its core concepts and moving towards its profound implications. Dive into the genius mind of Einstein and discover the universe anew. Welcome to the world of relativity. Imagine a universe where motion and gravity are redefined. This is what Einstein introduced with his groundbreaking theory. At its core, relativity explores how different observers perceive motion and forces like gravity. Einstein's theory divides into two parts: special relativity, addressing motion without gravity, and general relativity, which includes gravitational forces. Relativity teaches us that motion and gravity depend on the observer's frame of reference, challenging the absolutes once thought true. This insight changed our understanding of the universe, setting the stage for further exploration into space-time. Buckle up as we delve deeper into these concepts and discover their impact on our world. Next, we'll explore the intricate tapestry of space-time and its connection to everything we know. Imagine the universe as a giant, invisible fabric that stretches and bends as you move through it. This fabric is called space-time, combining the three dimensions of space with the fourth dimension of time. To simplify, think of a trampoline. When you place a heavy object on it, the trampoline sags, creating a dip. In our universe, massive objects like planets and stars create similar dips in the fabric of space-time. Now, consider a marble rolling across the trampoline. As it approaches the dip, its path curves. This interconnectedness of space and time affects everything from the trajectory of planets to the flow of time itself. Einstein's theory of relativity suggests that the more massive an object, the more it warps space-time around it. This relationship explains why time ticks slower near a massive object compared to far away from it. Understanding space-time isn't just an academic exercise, it's a gateway to grasping how our universe truly functions. Up next, we'll delve into how this bending of space-time affects time itself, exploring the fascinating phenomenon of time dilation. Imagine you're on a train speeding close to the speed of light. As you gaze out the window, the world appears to move in slow motion. This isn't just a trick of the eye, it's a phenomenon known as time dilation. At its core, time dilation shows us that time doesn't tick uniformly everywhere in the universe. It's influenced by speed and gravity. The faster you travel, especially as you near the speed of light, the more time stretches out for you compared to someone standing still. Picture this: astronauts aboard a high-speed spacecraft age more slowly than their counterparts on Earth. This isn't science fiction, it's Einstein's theory of relativity in action. To illustrate further, consider two twins. One stays on Earth while the other embarks on a journey through space at near light speeds. Upon returning, the traveling twin finds they've aged less than their sibling. This twin paradox is a classic example of time dilation at work. Time dilation challenges our everyday experiences and reshapes our understanding of time itself. By making these concepts relatable, we can appreciate the profound implications they have on our universe. In our next segment, we'll delve into how gravity plays a crucial role in shaping space-time, offering yet another layer to Einstein's groundbreaking theory. Stay with us as we continue to unravel the mysteries of the cosmos and bring these complex ideas into clearer focus for all curious minds. Imagine if gravity wasn't a force pulling us down, but rather a curve in the very fabric of the universe. This is what Einstein proposed with his groundbreaking theory of general relativity. In this framework, gravity is not a traditional force. Instead, it's a bending of space-time caused by mass. Picture a massive object like Earth resting on a stretchy fabric. Its weight pulls down the material, creating a dip. Now, if you roll a marble nearby, it spirals inward, drawn by the curve. This is how gravity works according to general relativity. Massive bodies like planets and stars distort the geometry of space-time, affecting the path that objects take when moving through it. This bending of space-time explains why planets orbit stars and why light bends around massive objects. Using visual aids, imagine these celestial bodies on a trampoline, their weight creating depressions. Smaller objects naturally move along these curves, just like marbles on our trampoline model. This visualization helps us grasp how mass affects space-time, without delving into complex equations. By understanding gravity this way, we unlock a deeper comprehension of the universe's structure and behavior. This segment bridges our exploration of space-time with the discovery of gravitational waves, which reveal even more about these cosmic dances. Stay with us as we delve into how these ripples in space-time were detected and what they tell us about the universe's most dramatic events. Einstein's insights continue to guide our journey through the cosmos. Imagine the universe as a vast cosmic ocean. Now, picture massive objects like black holes colliding, sending ripples across this ocean. These ripples are known as gravitational waves. First predicted by Albert Einstein over a century ago, they were finally detected in 2015. But how do we catch these elusive waves? Scientists use incredibly sensitive instruments called interferometers, which can detect the tiniest distortions in space-time. The discovery of gravitational waves opened a new window into our universe. They allow astronomers to observe phenomena invisible to traditional telescopes, revealing secrets of black holes and neutron stars. By understanding these ripples, we gain insights into the very fabric of our cosmos and its tumultuous history. As we continue our journey through the wonders of relativity, let's explore how these groundbreaking discoveries shape our understanding of the universe and our place within it. In our everyday lives, we rely on technologies that seem almost magical in their precision and reliability. Behind this magic lies the profound science of relativity. Without Einstein's groundbreaking theory, your GPS system would lead you astray, as it depends on incredibly accurate time measurements between satellites and receivers. These satellites, high above us and moving at great speeds, rely on relativity to ensure their clocks stay synchronized with those on Earth, providing the precision we depend on every day. But GPS isn't the only marvel. Consider the advancements in physics research. From particle accelerators probing the smallest building blocks of the universe to advancements in nuclear energy, relativity is the invisible hand guiding these technologies. It provides the framework for understanding how particles behave at high speeds and under intense gravitational forces. Even in telecommunications, relativity plays a role. As signals traverse vast distances through space, they must account for relativistic effects to maintain clarity and speed. These applications remind us that relativity isn't just a scientific abstraction. It's a vital part of our technological landscape, enhancing our understanding of the universe and shaping our future. As we conclude this exploration of relativity's real-world impact, let's reflect on how this theory not only redefines physics, but also enriches our daily lives. Join us next as we delve into Einstein's enduring legacy, exploring how his insights continue to inspire scientific innovation and curiosity. As we conclude our journey through the fascinating world of Einstein's theory of relativity, let us reflect on the profound insights we've uncovered. From the bending of space-time to the mind-bending concept of time dilation, Einstein's ideas have reshaped our understanding of the universe. These theories not only revolutionized physics, but have also paved the way for technological advancements that touch our daily lives, like GPS and beyond. Yet, the true beauty of Einstein's work lies in its ability to inspire continuous exploration and innovation. His legacy challenges us to question, to imagine, and to explore further. Whether you're a student, a scientist, or simply curious, Einstein's theory invites you to delve deeper into the mysteries of the cosmos. So as we wrap up this segment, remember, the universe is vast, and our journey of discovery is just beginning. Let's keep exploring, questioning, and learning. Thank you for joining us on this enlightening adventure into the cosmos.